Here's another thing that I've just started pursuing. It's not a complete. It's not complete, but what this is it starts from an open source project that I found on Control Shift R, Control Shift V. It's forked from a repo online. I've cloned it and um, and made a lot of adjustments to it. But check this out. I am going to say that when you're calculating risk scores and processing everything, it might be a good idea to do parallel implementations in order to make sure that risk scores are accurate. So if you make some sort of change to your processes, code changes, that's going to result in new risk scores, new metrics coming forth, and you need to be confident that those are correct. Through reasoning, you do this, through thinking, but also just attacking it from two different angles. So there's this method out there. I read that for ACA, the HHS will put out a new Python implementation, and so you have currently a SAS implementation, soon to come a Python implementation, and we have like a SQL implementation and probably numerous others. And so maybe it's possible to have 2 or even 3 implementations of risk scoring going on. So that said, let me pull up some docs that are going to be rendered, since VS Code doesn't want to render this all very well. In this project, we use dbt in combination with a 3,000-line SQL script found online, which is forked from GitHub. We seed the data. It loads into reference tables. This visual right here, I guess the very detailed implementation isn't useful, but what's kind of cool is, for documentation's sake, creating these things called mermaid diagrams. And mermaid is something that is popularizing, and we can do all sorts of code to visual diagrams with it. We can do flowcharts. Below, we can do entity relationship diagrams, which I think is broken right now and I need to fix. Here's the ERD, which is working. What's cool about this is that we can really just write code, and we don't need to use that Microsoft Visio tool or anything like online like Chart.io, etc. We have tools that are native to the computer now. If I scroll up, we have diagrams which show how this process would work, where we populate our 4 basic tables, which are submitted to the Edge server. I think this is true, where we have the supplemental, which comes from adding DX codes and mapping those throughout the year. But the process is, we create these 4 tables and we run some scripts, and in the end we get a list of ACCs that have been identified. What else can I say about this? What can I say? Yeah. Yeah, so I think that pursuing this would be here's an idea. We can do waterfall analyses on year-over-year HCC lists. So the idea is this. It's something familiar. I do this for work currently, but every year we have data changing and we have models changing. And in order to understand the impact year on year of different aspects of changes, we can decompose it by introducing each new factor individually, measuring the impact, and quantifying things. And so I wonder if I have if I have a cleaner right up here somewhere. I don't, I guess. Man, I thought I had a table. Yeah, this is what I'm thinking of. You're running 2025. You've got your old population or cohort data. You've got your old coefficients. The DIY model changes every year. We get new coefficients in that. So we want to understand what impact the coefficients have. We can rerun our risk scores using the old population, introducing the old data tables. We flip out the coefficients and rerun, or the DIY model. Then step 2 or 3 here, we'll change the cohort or the population data, our member data, then we'll use previous year coefficients, and then we can combine in the last step to do all 3. There's other ways to do it, like you can parse out if there's any interaction between the population and the coefficients, you can isolate the changes without the interaction effect. And then there's also ways to further refine this, like we can introduce other analyses. I don't know, I guess the world becomes your oyster at that point. Got some other ideas here. I wonder if I can't pause this video, so I wouldn't be able to really quickly summarize this, but let's say this. Throughout the year, we're going to get more data as we go, and as a result, you can run this analysis. You can use what's our risk score up to July, and what was it last year, and so we can kind of see like the risk scores, the HCC counts increase in count and severity over time, and we can compare year on year, where are we right now compared to last year, and see if we're on target to reach our goals. Look at this too. So decomposition, I think, is pretty neat. Gosh darn it. But something else that's really cool is this. Where did I put my config? There it is. So I would do an elevator pitch to say that we should have some sort of, in order to manage all the decomposition settings and various analyses, it would be good to set up a job orchestrator that you can run jobs through, log the results of, give it a unique ID, and then be able to compare analysis on analysis. And so if you run risk scores for 2025 and then again in 2026, you kind of left join those tables and find the difference in, let's say, risk scores. Maybe absolute A minus B or absolute A over B for ratios. There's a lot of steps, but if you can manage to construct some medium difficulty job orchestration and tracking tools, then all the following becomes quite useful. You have this config file, and when you configure, change, we're going to analyze the year 2024. You can run the script, which is the goal would be to run parameterized DIY model, which would change it. It deletes the top parts of this DIY script where we're declaring 2025 to be the benefits year. That's just default. You can configure the YAML, and when you click go on the Python script, it deletes this section and it replaces it with whatever's defined in the configuration file. And so you can, no need to edit these different variables. What's cool about this is when you git commit, git push this to GitLab, now your code is static, and you don't need to, when you parameterize things differently or change variables, your code is static, and so you know that the code doesn't change. And so when you see differences over time, you just know that it's due to the variable settings that you're configuring each execution. Going really fast on some of this, but look at this. You adjust the paid through date. Maybe it's the end of the year and you have 12 months worth of data. You can kind of see how data changes throughout the year. You can filter down to each state. Here, Pennsylvania, maybe different counties. Look at different markets. Look at different HIOS IDs. When it comes to decomposition, you can, use the 2024. This would be the baseline scenario. We're using 2024 data, 2024 model. You want to check the regulatory impact. You're just using next year's model with the previous year's data, and so on. And so you're introducing these pieces one at a time. You can also parameterize it to load different data sets, such as, well, what if our enrollment changes? Like we could customize we can have different base tables of enrollment, medical, pharmacy, supplemental, and run the same analyses using the same coefficients, using overall the same data, and just kind of see what these different tables are doing for the impact. And there's, I don't know, like a lot of downstream implications that you could look at. You can measure the impact of chart reviews, maybe looking at supplemental, but I have hit 11 minutes, so I'll stop, but that's cool.